Okay, so from this week we will talk about Z language. Okay, I don't know if you have take a look at it. Have you ever previewed a little bit? It's fun, right? Okay. You may feel sleepy when you just reading that and don't know anything about it. Okay. So here, what is Z? Right? Z is the most widely used formal specification language. So it's a whole set of rules that help you to specify the system with the functions, with those elements. Okay, and it's developed at Oxford University and requires knowledge of functions, set theories, discrete mathematics, and the logic. Okay, so we have already learned those propositional calculus, okay, those kind of things, and set theory, and those things. So we already have this basis to learn this Z language. It might take you a while to memorize a lot of things. However, everything is not that hard to understand, trust me, okay? So don't feel that you cannot make it. It just takes time. Sometimes it just takes time. Okay, so you will meet this kind of symbols, right? So we've already been pretty familiar with those implies, right? This is imply. This is the union. What is this? No, it exists. It's reversed, right? Remember? So it's a typo. Actually, it belongs to. Yeah.
Stuff is supposed to be the subset symbol?
Yeah. It belongs to a subset, something like that. It's a typo. Sorry about that. Yeah, and we will also meet this type of things. You will know that later. That's fine. Okay. So this specification consists of a number of schema. Each schema is a small chunk, consists of a group of variable declarations together with a list of predicates. Right? We learned that what is predicates that constrain the possible values of the variables. They are built incrementally. If you cannot understand what this is talking about, you will know that when we get into an example. All right. And the simplest form of formal specification requirements, formal specification represents a system as a set of functions with hidden internal states. So each function is specified with pre and post conditions. So we learned what is the pre and post conditions, right? Last week, the week before last week. So the post condition and precondition means those conditions you have to make before and after that function is executed. Okay. So do you still remember what is a function? And we know what is function, right? A function. We all know, if we have learned a little bit about programming, we know what is a function. What it, like our method or something like that. Here I want to give you a little bit about more formal definition of that function, of what is a function. Okay, so it's actually in this textbook, but I will make it easier for you. Okay, so when we talk about function, the formal definition is when a pair of elements occurs in the function, it is said that the function maps the first element to the second element. Okay, to the second element. All right. So a function means when you give think about the function when you're doing the programming, right? When you give a set of input, when you give an input, a certain input to that function, you will get an output from that function, right? When you give another input, when you give the same input, you always have the same output, right? Is that true? No? If all the input is the same, including the global variables, the local variables, if you give all the input, same input, you will get the same output. Okay. So that's how we do with functions. So we have, if you still remember the relation, domain and range, right? Domain is the first element, range is the second element. Domain is the set of the first element. Range is set of the second element, right? Okay, so a function actually it maps from elements from domain to another elements of function. Okay, so that creates many different kinds of function. Okay, and function is simple, just the mapping from the domain to the range. Okay, if you give one element in domain, you get an element from the range. Simple. But another thing is called a partial function. So a partial function is a function whose domain is a proper subset of the set from which the first element of its pair are taken. So it sounds complicated, but that means a partial function. Okay, if that function takes the input, which is the natural number from 1 to 10, okay, then we can say this is the partial function over natural number by natural number, because it doesn't map all the natural number there. It just maps a subset of the natural number, which is from 1 to 10. It's you give 1, it returns you 2. You give 2, it returns you 4. Maybe it's a time 2, something like that. However, it's only care with the subset of it. So that's called a partial function. Okay. So you know what is a total function? Total function means all the domain included. Okay. So just some concept I want you to know. A total function. Okay, and an injective function. Remember that injective function. What is injective function? Injective function is a function whose inverse is also a function. You got that point? A function is when we say we can map one input to the exact another to an output, okay, from the range. But a function cannot map anything from the range to the input. Okay, so it only gives, when you give an input, it gives you output. Okay, but it does not guarantee that every element in the range can be mapped to another element in the domain. Okay, let me give you an example so that you know what is that. Okay. Let me write it down here. Okay, just do it here. Okay. So this is maybe 1 maps to process 1. Okay, if we have something like this, can you see that clearly? Can you see that from the back? Okay. Okay, so this is kind of those relations here. The relations here. Okay, if we want to see this is the relation of mapping from maybe an ID number to the actual process. Okay, so here we can see the system has only two process. It's only two process, but it actually has 4 ID numbers there, mapping to those 2 processes. So if you like input ID 1, it will give you process 1. Input ID 2, it gives you process 2. But if you input ID 3, it gives you the process 1, still process 1. If you input ID 4, it gives you the process 2. It's kind of so it is a function. I can tell you it is a function, okay? Because you can get this ID number or natural number or something like that. We don't care if it's a partial of total function, but it is a function because it maps an input to an output. It maps one input to one output. Okay. So like if you have 1, we have a process 1. If you have 2, we have a process 2. Okay. Let's see if this is the second mapping. Let's see if that is a function or not. This is a function. Let's see, what is this? How about this second line here? Okay, please feel free to interrupt me anytime if you get lost, okay? Okay, for this second line, do you think that is a function or not?
No, it's not a function.
Is it what?
I don't think it's a function.
Right, so what's the reason? Why don't you think that's a function?
Because 1 appears both times. It's the domain for 2
Okay.
different ranges.
Yeah. Yeah. So that's true. So when you are having this 1, the input, if the input is 1, it's actually mapping to 2 different output, right? So that makes it not a function. Okay. So the function has, you give 1 input, it has to be mapped to 1 output, not 2 output, not 3 output, okay, not 0 output. So this is not a function. And how about this one? Process 2, process 3. Process 4. How about this one?
It's a function.
Sure, why not?
Yeah, it's a function. Like a perfect function, easy, right? Function. Okay, so let's talk about partial function. Partial function, when I mentioned the definition is this. No, the injective function. An injective function is a function whose inverse is also a function. What does that mean? That means inverse. Okay. So let's see. It means if you give an element in the domain, in the range. Sorry, if you give element in the range, it can be mapped to another element in the domain. Exactly one. Okay. So let's see. Is this an injective function?
Yes.
Yes, this is an injective function. Okay, that's nice. You all get it. How about this?
Yeah. No.
I know, because the process 2 can be mapped to two different numbers, right? And how about this? Is this the injective function? How many of you say yes? How many of you say no? Okay, right. It's not injective function. It's a function because you can map 1, 2, 3, 4 to different. You can map 1 to 1. So that's one. You have one element mapped to another element. However, if you reverse that, you can see you have this process 1 mapped to both 1 and 3. If you reverse that, so that's not injective function. Okay, function, but not injective function. All right. If we mix this function, the injective function concept, with the partial and the total, okay. So injective function can be classified as partial and total. So a function is injective function. It's a partial injective function. Can you try to define that? What is a partial injective? Think about partial. Partial means it's only a subset of something. Injective means inverse, reverse. So partial injective means just describe. We can use predicate to formally define that, but maybe if I expand that, maybe make more sense. Okay, so if it's a partial injective, first it is an injective function. Okay, it is an injective function, so you can map from domain to range, and also from range to domain. Second, it's a partial because the domain is a subset of another thing. Maybe the domain is natural number from 1 to 10. Okay, that is actually a subset of natural number, right? So all these they are actually partial. This is a partial. This is a partial injective function. This is a partial injective function over the natural number by process. Okay, this is a partial injective because first it is injective and then it's partial. Let me repeat it again in case you forgot already. So injective means it can map from domain to the one domain mapped to one range. Injective means not only one domain to one range, but reversed, one range to one domain also work. And partial means the domain is a subset of another thing. Okay, and total means the domain is the whole set of natural number or a whole set of something else. All right. Partial and total is easy to understand, right? Partial is like the domain is not the whole set. Okay. Total means the domain is the whole set. But injective means function means you can map from domain to range. Injective means you can map from domain to range and from range to domain. Okay? Okay? Got that? Okay, so that's good enough for now. Let's continue with Z. Also, if you continue read, you can. There are more things like surjection, injection, surjection, things like that, which is even more confusing. But let's leave it for now. Okay. Okay, so you got the idea. What is function? What is the partial function? What is injective function? Right? Okay. All right. So a schema. We use this Z language to model this system as a group of variable declarations, those functions. Okay. Schema. Simplest form of formal specification represents a system as a set of functions with hidden internal state. Each function is specified with pre and post conditions. Remember that, pre and post conditions. When we specify post conditions, usually we use a prime. Remember? We use a prime to represent the value after the execution. Okay. Still remember? What is the prime, right? Like the input is the time, and output is the time prime. Okay. Sometimes if you want remain the same, you just time prime equals to time, something like that. So we write down those pre and post conditions as the predicates over inputs and outputs of a function. So predicates is simply a Boolean expression, we all know that, whose variable are parameters of the function being defined. Remember that? What is predicates? Yes, you still remember. Okay, so this is basically the format of the schema. Setting up a directory of social security numbers. So it takes a social security number as the input and returns the name of the person with that social security number. Okay. So basically here is this one is the format, how you define that schema. Okay, the S is the schema name. Okay, and then you put a name there and the S, replace that S, and the declarations just tells you what kind of, maybe something like variables, elements there you want to declare. And predicates here is the place you want to define your pre and post conditions. Okay, pre and post condition. And also the second one is the format that you declare some constants. Yeah. Let's see the example. Okay, so this is the social security directory. Okay, so here we have this number. Number is, this P means a set. Okay, the set of social security number. Name is defined as a set of entry name. Okay. So this social security direct means it's a mapping, it's a function mapping from social security number to the entry name. Alright? So P is a set of. Okay, let's review that. P is a set of. So number is basically a set of social security number. Name is a set of entry name. Okay, So the directory consists of a collection of numbers and names. Okay, so what is in that directory? First, it has a set of security numbers, social security numbers. Then it has the set of entry name. Okay, entry name, and this is the actual function. Okay. Let's see. So this symbol means partial injection. That's why I want to explain what is partial injection. So this means partial injection means 1 to 1 but not down to. Okay. So this symbol here, it actually means okay, this is a function mapping the social security number to the entry name. When you enter a social security number, you got the name of that person. Okay, that makes sense? But what is injective? What is injective? Still remember what is injective?
If you have the name, you would have the social security number.
Yeah, if you have a name, you would have a social security number. So do you think there's some problem there?
Yeah. It's not injective.
Yeah, because the name, it can be like the same. Two persons can have the same name, with different social security number, right? So I'd rather say it's not a partial injective. It's a partial function, but I don't think that's a partial injective. Okay. However, this material tells us it's a partial injective, but I don't agree. But okay, you can make assumption that no person has the same name as the other person in this directory. Then we can consider this as a partial injective. Okay, partial injective. Yeah, so Z allows us to defer definitions by using the caps. So the social security number and entry names definition have been deferred. Their precise specification isn't known or is not important now, so we can just leave it there. So basically, social security directory is a function from the set of social security number to the set of entry name. Okay, so the domain. The domain is the social security number, right? The range is the entry name. It's a set of entry name. Okay, and social security direct is a function that maps from social security number to entry name, right? That's not hard. It's a function mapping from one to the other. Okay. So if we make that assumption that no, they all have a different names there. Okay, so we can call it partial injection. But why do we call it partial? Try to memorize what is a partial.
Subset of a different set.
Subset. Yeah, subset. Okay. So social security, what is that? Social security usually do we know the whole set of what social security is?
It's a set of natural numbers.
Yeah, it's a set of natural numbers. How many digits are there?
So 9 digits, I think.
9, right?
Yes.
9. Okay, 9. So basically, it's a natural number from 1 0 0 0 0 0 to 9 9 9 9 9 9 9. Okay. So that's social security number, right? And basically not all the numbers are used for Social Security yet, right? Because there are still maybe you can still generate new Social Security number for newborn, right? So not all numbers have been used already. So that means, okay, Social Security number is the domain set. That means we only map a subset of the Social Security number to the names. That's why we call it partial. Okay, that's why we call it partial. So not every 9-digit number is a valid Social Security number. And also it's a function because you give a Social Security number, there's no way it will return 2 names to you, because everyone is assigned with only one Social Security number. Okay. No, I should say this. Every Social Security number can only be assigned to one person. Okay. I don't know if they do the recycle. Let's just assume it's not. They're not doing recycling. Okay, and this is how we define this. Okay, remember the 2 different formats here from here. This is how we define this functions, the schema, and this is how we declare some maybe elements here. Let's see how we define this. So this is the second format. How we specify the Social Security number. Okay, so we define Social Security number as a set, as an affinity set, which is F, of natural numbers, and then the second part here we use a predicate to further refine what that Social Security number is. So this is like a signature. Well, it belongs to affinity. It's a finite set of natural numbers. Okay. It belongs to natural numbers. And Social Security number, this belongs to 1000 to 99999. Okay. It must be 9 digits long. It must be 9 digits long, and it cannot start with 0. Okay, cannot start with 0. It cannot be less than this number over here, 100000. So that's the format to describe what the Social Security number is. Okay. Also, this number 5 is the same here. We are trying to describe what is the entry name here. Okay, so entry name is a sequence of a character. And what does this mean?
The name has to be less than 40 characters?
Yeah. The length of the name has to be less than 40. It has less than 40 characters. Yeah. Up to 40 characters long. So remember this format, 2 parts. First is kind of the signature. Second is the predicate. Predicate is used to, the signature is maybe specify okay, what this thing is, what set it belongs to. And this predicate is used to further refine that range of this entry name here. Okay, and let's go back here. the schema is the schema's name. In this case, it's Social Security Directory. Okay, and declarations. In declarations, we specify. In declarations, we specify like a signature of what is name, what is number, what is name, and what the function is. The function, what the function maps. Okay, what the function maps to. The function maps from a set of from the Social Security number to the entry name. Okay, so it kind of tell you whether it is a partial or total, and it's injective or not injective, with different symbols. But also it tells you what is the domain set, what is the range set. Okay, so this is schema of another thing called insert new Social Security entry. Okay, insert new Social Security entry. Okay, let me explain that a little bit. So this triangle Social Security Directory, the delta schema for insert new Social Security entry. The triangle denotes this operation change the state of the Social Security Directory. Okay, so that basically indicates what this operation will change, right? And how about this number question mark?
So input.
Yep. So var, the question mark, it's input. Okay, and also we can define this output as well. Alright, so it tells you clearly what is input and what is output with question mark and exclamation mark. So here in this case, the number and the name are the inputs variables. Okay, and the Social Security Directory is the thing we would like to change. Okay, and you still remember this part? That part in the format is called predicates. So it's a predicates to specify the pre and post conditions of this operation. Okay, let's see, what is it? Does it make sense? So this is the precondition. The number, the input, doesn't belong to the domain of the Social Security Direct. Can you understand this part? The domain of the Social Security Direct is the set of Social Security number that has already been exist there. Okay. So Social Security Direct is the mapping from Social Security number to the name, and there are already a whole bunch of Social Security number there and a whole bunch of names there. And right now, in this insert new Social Security entry operation, we're trying to insert a new mapping. Okay, insert a new mapping, maybe from your Social Security number to your name. Okay, so that requires the new number you are going to insert doesn't exist in the current domain of the Social Security Direct. Okay, that makes sense? This line makes sense? Okay. And the second line is the post condition. Post condition. And this is a new mark here. Yeah, this is the mapping from number to name. It means mapping. Okay. So basically, this is the post condition. So there's Social Security direct prime equals to social direct. This is old value. This is original value of the social direct. Union a new mapping from the number, from the input number to the input name. Okay, that makes sense. That is actually the operation of insert, right? That is operation of insert, right? Yeah, you have a new entry, you add it to the old entry with this union. Okay, union, it forms a new set, right? So that means after the execution, Social Security direct prime is the value after the execution. Okay. So this is how we define this insert new Social Security entry. Let's stop here to see if you have any question on this part. Okay, if you do not have a question, I will ask a question. So how can we distinguish the post condition from the precondition?
The post condition is what happens after the inputs are entered into the system, and the precondition is just what needs to be true. What needs to be true for the post condition to be true.
Yeah. So that's actually the definition of that. So the precondition is, but here we actually mix all of them together, right?
Right.
So the post condition, precondition. But actually it's easy to distinguish just with this prime, right? You cannot you cannot test this condition at all before the execution, because there's no Social Security direct prime. There's no such a value before the execution. This value only exists after the execution of this method, right? So this is definitely a post condition. Post condition. And how about precondition?
Precondition is above post condition.
Yeah, this precondition, we can switch the order, but still this is a precondition, this is a post condition. But this precondition, this no matter when you before or after the execution you test this condition, it's not gonna change because it doesn't have anything that included that prime. Okay. So it doesn't matter. So you can test it anytime before and after. Okay. But this you won't be able to test it at all before the execution. Okay. So that means when you're trying to test the post condition, you can only test it after the execution for sure, because that value cannot exist. But for this preconditions, you can test it before and after, but if it's true or false, it won't change. So you only have to test it once before this precondition, before the execution. Okay, that's how. So that we do not have to have a separate column for a separate line for precondition, a separate area for post condition, we can just mix them together because they are all predicates. They should be true. They should be true simultaneously. Yeah. If something change, that means prime. That you have to add the prime there. Yeah. The post condition. Yeah, this is some explanation from the material. So in the above schema, the precondition says number must not be a member of the domain of the Social Security Direct. And post condition says after the operation insert new Social Security has been performed, new number and the name are added to the directory. I say this is still true after the execution. Have anyone doesn't agree with that? After the execution, number does not belong to the domain of the Social Security Direct. After the execution. It's easy to get confused to this part. Okay, so this is still true after the execution. Because you think when we add the number to the Social Security Direct, the domain of the Social Security Direct should have already have that number, right, after the execution, right? But here, since we are not putting this prime here, okay, so this still true after the execution. So basically, this is a precondition, this is a post condition. Easy to distinguish them. Okay, so some symbols here. Other symbols we are pretty familiar. Disjunction, conjunction, set union, and another thing is called overriding operator. So this act like set union if so override acts like set union if that thing is not in the set, but if the name is in the set, the name and associate value are replaced. Okay. So that means override. It's a circle and a plus. So override and the union do not get them confused. Do not get confused by them. Union is you add a new one to it. Just add a new one to it. Override means if that exists, then you got that replaced. Okay, let's go back here. Just for this insert new Social Security entry. Okay. Let's write something new. Let's write insert new Social Security entry without this union note, without the union symbol, but we're using override symbol. Okay, let's try to do that. Grab a piece of paper. Let's try to write this insert new Social Security entry operation with the override symbol instead of union symbol. Okay, override symbol here, it means it acts exactly like the union if that element doesn't exist here. But if the name is in that set, the override will replace that association. Okay, that means override. If it doesn't exist, we put it there. If it exists, we replace it. That means override. Okay, so let's write another specification for insert new social security entry with the override symbol. Okay, let's try. Okay, so this is not hard, so it shouldn't take a long time. So can anyone tell me what has been changed if we replace this union with the override?
The union operators just changed it to the plus circle.
Yeah. Yeah, that's one change. We changed the symbol, yeah. What else should we change? Okay, do you think we still need this precondition at all?
No.
Right, we can remove this. The main change is here is override, and we remove this precondition because if we're using override, we can replace something that existing there. Okay. If something already exists, we just replace it. We don't have to make sure that the new number doesn't belong to the domain of Social Security Direct. Okay. So that's amazing. You should realize we need to remove this precondition. Okay. Okay, let's try this one. So this is phone information maps names to numbers. Okay, so this is just want you to learn, get more familiar with the logic of override. Okay, so the phone directory is from mapping from a name to this numbers. So the domain is the names, the range is the range of the phone is those numbers. Okay, range of the phone is the numbers. So give a new function, new phone. Okay, so this is the new function, new phone, and it's still mapping from a name to a number. Okay, a name to a number. So now let's see what is the result of this phone override new phone. Okay, phone override new phone. What is the result there?
Steve and Ron are added.
Steve is replaced, Ron is added.
What was that? I haven't here. What did you say?
The range entry for Steve would be replaced with that thing, and then Ron would be added on at the end.
Yes, exactly. So this operation will give you first in the phone the Ron. Okay, it should be Ron, right? Oh, Steve. Okay, Steve should be updated to 3386, and then you put Ron there. That's the operation of override. Okay. So here, it's still the ein. Shoot. It's mapping from ein to 3690, so it still remain the same. It just updates the Steve and then insert the Ron. So that is the override operation. Okay, so given this operation, that means when you're doing override, you do not have to make sure that the new entry doesn't exist in the original mapping. It exists or not doesn't matter, because we have an operation for both situations. This is another thing called a domain subtraction operator. So operator used to remove an item from a set. Okay, so if you're trying to remove this iron from the phone, it will result in this Ray Steve, but iron removed, the mapping removed. Okay, so this is a remove, simple to understand. Okay, so till now you have get a very rough, basic idea about this specification. So it's not hard at all. It's just a bunch of different areas, okay? But in different areas, it defines different things. That is define the name. That area define name. That area you define those elements, those signatures of those elements, or input, output, what you'd like to change. Okay. And here you specify a whole set of precondition and post conditions. Okay. Another thing you need to remember here is how you define those okay. How to define this elements here, like how you define the social, what the social security number is. It's still similar. When we're doing the predicate, we have the signature, which gives you a big range. right? It's a set of it belongs to natural number. Okay, it belongs to something else. Okay, and then we give a predicate to further refine what that is, what the social security number is. And the entry name is the same. First, we give a very rough set to define what is the entry name. So it is actually a sequence of chair. And then we use predicates to further restrict, to refine what is the entry name here. So the entry name here is the number of entry name should be less than 40. The number of the character should be less than 40. Okay, so we use this type of thing, this schema, those formats, and plus our knowledge with predicates, those things. Then and also precondition, how you define this precondition and postcondition. Then we should have enough tools for us to specify a system. If you assume that the system have a whole bunch of functions there and a whole bunch of the element there you want to define. Okay, so yeah. So something just a little bit confusing. Something a little bit confusing is the function. When we're trying to formally define a function, it's mapping. It's mapping from the domain to that range, and there's a set of those mapping. We call it function. Okay. And still remember what is partial, what is injective. Okay. So that would be good enough for this class. Okay. So any questions on this class? I hope you can still read through this material again when you go home. And so that you won't forget this. And we can talk. We will talk more about it next class. Okay. All right. Thank you. Any questions? Any question? Okay. Cool. Thank you very much for today.